Hello, grade 10s. This is the lesson for Tuesday, May 19th. There was nothing posted Monday because it was a holiday. So, out of the 26 people in our class, 14 have written the test from last week, so it's a little over half. But I've got to keep going, so hopefully you'll get that done when you can. And again, at this point, I think the biggest priority here is to make sure that you are prepared for your grade 11 university level math or your grade 11 college math. And whichever math you choose to take next year, you do need to know the material that we're covering here. And certainly if you plan on taking the 3U course, the university level math, you really need to know this. Because if you get in that class next year and you haven't done this stuff during this time, I think you're really going to struggle. And unfortunately, that will probably carry through into your grade 12 year as well, and that's when marks really matter. So take the time now and do this stuff. And if you have a friend that's just not bothering, try to get them to do it, because in the end, it will be of a huge benefit to you if you know how to do this math. Okay, so we're in a new unit. It's called quadratic equations. It is the last quadratic equations unit, the last quadratic unit, pardon me, in this course. So let's get started. All right, question 1, solve for x. This is our first 5-minute question. As always, I encourage you to pause, try the question, and then come back. Okay, so you might not have had any idea how to get started. So let's say you're in grade 9, okay, or grade 10, and I give you this. 3x plus 1 equals 7. And I say solve for x. Well, you know what to do. You subtract 1 from both sides and you divide by 3. But all of a sudden, in this equation, we have multiple x's. So you can't isolate x, right? You can't just move everything over except for an x because there's x's in two different terms. So what we have to do is we have to isolate x, but we have to kind of do it twice. And to do that, what we end up doing in the end is factoring. Now, you may have done this, but let me tell you that this isn't really going to work. It's going to be a lot of work from this point forward. It's possible, but it's just going to be guess and check. So instead, what we do is we bring that 8 over. So I'll show it. I'm not going to show it every time because we should be able to do this by now. But I subtract 8 from both sides, and I get x squared plus 2x minus 8 equals 0. And now we're going to, in quotes, solve for x. Now it's really important, probably the most important thing for the first day of this unit is that when I say solve for x, so solve for x when dealing with a quadratic means factor. Okay, so solving for x means factor. You factor it and then you look at the zeros. Okay, so it means factor, find the zeros, and those zeros are the solutions, because once we rearrange this, we want to know when does this thing equal 0, or what are the zeros. So let me move that up there so it's there at the end for people that skip through the video. And now we got to factor it. We need two numbers that multiply to -8 and add to 2, and we have x plus 4 and x minus 2. If you don't believe me, you can FOIL and check it, but we're not done yet. Now we would say, therefore, x equals -4, because remember, we have to change the signs when we find the zeros, and +2. So we solved it. So what this means is that when x equals -4 and when x equals 2, x squared plus 2x is 8. Let's check. Let's put in 2. 2 squared is 4, plus 2 times 2, that's 4, so 8. -4. So -4 squared would be 16, plus 2 times -4 would be -8, so 16 minus 8 is 8, so it works. All right, let's get started on the new unit. On your handout, we have some new terms. So here we go. The first definition over here says an equation that contains at least one term whose highest degree is 2. Now, I'm just going to go ahead and tell you that this is a quadratic equation. Okay, and I'm going to tell you that degree 2 means we have an x squared. Okay, and an example would be x squared plus 2x minus 8 equals 0. Okay, so that one's done. A solution, a number that can be substituted for the variable to make the equation a true statement. These are solutions, and another word for solution is a root. And you're going to hear that a lot. You'll hear it a lot more in grade 11, 12, and university if you take math. This root comes up a lot. So here we would say x equals, what was it, -4 and +2 are roots. And I'm referring to the equation above. Next one, a process used to rewrite a quadratic relation in standard into vertex form. This is completing the square, and this is going to be an entire day in this unit. Completing the square. Okay, and I can't give you an example of that because it doesn't fit in the box. A formula for determining the roots of a quadratic equation in standard form. And you might be like, oh, that's factoring. But factoring's not here. So there will be another day where you will learn the quadratic formula, and there's a little song that goes with it. It's super fun. Quadratic formula. All right. The set of numbers that corresponds to fractions, decimals, integers, and irrationals. These are just real numbers, and this will be a minor thing. This will be a much bigger thing in grade 11. And this unit, we just bring it up. And finally, this is the discriminant. And again, at this point, it's meaningless. So I'm not going to do examples of these. I'm not going to go over them too much because they will come up later in the unit. I just wanted you to see them before we got started. Okay. So let's do two definitions, or basically examples. So a quadratic relation would be this. Y equals ax squared plus bx plus c. It's just a quadratic, right? You've seen it before. You're probably like, oh, that's a quadratic equation. Well, here's the difference. This would be a quadratic equation, where we have it set equal to some number. We're going to call this a relation because we could graph it, stuff like that, where this is more of an equation that we would solve. So if two numbers have a product of 0, then one or both of the numbers is 0. I think that makes sense, right? That's come up before. If you have a 0 and some other number, when you multiply them, you're going to get 0. I just have two examples today. It's really nothing new today, so let's get to it. So we're going to be solving quadratic equations, which means find the roots or find the zeros. It means solve for x. It all means the same thing. And for now, it basically means for you to factor. So step one, this is a really important step. Step one, make sure all the numbers are on one side of the equal sign. Okay, so it should look like this. This equals 0 is very key. Step two, factor. We spent a whole unit doing it, and I told you it's super important, and it's back. Step three, set each factor equal to 0 and solve. So here we go. Find the roots. X squared minus 6x plus 8 equals 0. So I know that that is x minus 2 times x minus 4 equals 0. So first of all, step one, it was already equal to 0. Step two, I factored. Step three, set them equal to 0. So x minus 2 equals 0. I add 2 to both sides, and we get x equals 2. But of course, you just could have looked at that and known that that would have been x equals 2. And here you can look, and obviously x equals 4. And those are my roots. Those are my solutions. Those are my zeros, if you will. And we're done. I just want to show you one more thing. So let's say we got this. So let's say we factored it, and I want to know what are the roots, because this is going to come up a lot. It's easy when it's like this, when it's just an x minus 2, but I just want you to take a moment. I encourage you to pause here and try it. What would be the roots of each of these brackets? And that means the solutions, the zeros, whatever. Okay, hopefully you tried it. So I set it equal to 0, just like I did here. I'm going to add 1 to both sides. So I get 2x equals 1. And then I divide by 2. and I get x equals 1/2. Or 0.5 would technically be fine here. And then for this other one, I'm going to get 3x plus 2 equals 0. I'm going to stop showing all those little steps because we shouldn't have to do that at this point. And there's my other 0. And honestly, if you went from this all the way to this, that's totally fine because you know that you're going to bring this over and change the sign and then divide by 3. So that's how you would do the roots if it wasn't a nice, easy one like this. Last question. I encourage you to pause and try the question first, and then unpause and see how I did it. Okay, so the user manual for Arlene's model rocket says that this equation models the height in meters after t seconds. When will the rocket reach a height of 63? Okay, so the first thing you'll notice is there is no 63 in here, so we need to put the 63 in. So we sub in 63 for height. And now we're ready to solve, or to start solving, and we go back to our steps. Step 1, make sure all the numbers and variables are on one side. Are they? They are not. So I subtract 63, and over where the constant is, I subtract 63 again. And I get negative 5t squared plus 40t minus 60 equals 0. So now I'm done step 1. Step 2 is factor. All right, now, you might think this is complex trinomial factoring, but this negative 5 can be factored out. So t squared minus 8t, I think it's plus 12 if I'm not mistaken. Okay, and now inside the brackets, I'm going to factor further if I can. And for now, you'll usually be able to because that's what I want you to do. So two numbers that multiply to positive 12 and add to negative 8, and that's going to be t minus 2 and t minus 6. So this means that my roots are t equals 2 and 6, but what does that mean for the question? Well, we set the height equal to 63, and then we solve for t. So basically what we found is the values of t when the height is 63. So this means that the rocket will reach a height of 63 meters after 2 seconds, and again after 6 seconds. And that's it. That's the whole lesson today. There's not much to it. The only really new part is you put the number in and bring it over. And I kind of feel like that came up in the last unit, but I'm not totally sure. All right, for your homework, I've assigned a lot of questions, but I've said do a few from each. So if you really can't factor, you're going to need to do a lot of these because you're going to need to remember how to factor and to get good at factoring. So look at the questions. If you see one, like maybe you look at number 4 and you're like, oh, A, B, and C are easy. And then you look at D and you're like, ooh, D looks tough. Well, then you should do part D. And also, do not hesitate to reach out to me. I'm happy to do a help session. I will probably schedule one for this week again, Thursday at 1 o'clock. That's what I've done for a couple of weeks. And I had 5 people the first time and I think 1 person the second time. And that's fine. If I work with 1 person for an hour, I think that person is going to be a lot better off. And I encourage the rest of you to come. And even if you don't have questions, you can sit in and listen, and you can learn from other people's questions. All right, folks, good luck with this, and don't hesitate to reach out if you need some help.